let's do some quick introductions. It's optional, so if you don't want to, you don't need to. But I'll go first. So I'm from the Robusta team and one of the maintainers. And Ari, do you want to go next? You're on mute.
So I'm also from the Robusta team, from the technical side, and yeah, also one of the maintainers. Pawan?
Yeah, hi everyone. I'm also from the Robusta team, one of the maintainers, MNC docs, and
Of neat. Can I ask you in the retro next?
Yeah. Hey everyone, I'm Bobby. I'm a product lead at Azure Kubernetes Service Microsoft. I'm a contributor to HolmesGPT.
Hi everyone, I'm Aritra. I'm part of the Microsoft team too. I'm a senior PM and we have been leveraging HolmesGPT and also contributing to it. Glad to be here.
Okay.
Yes, I can go next. I can go next.
Oh, go ahead.
This is Ani. My full name is Aniruddha Jadhav. I'm an engineering lead at AWS. I currently oversee observability and the UI frameworks and OpenSearch dashboards. We are primarily from the OpenSearch project, which was last year contributed to the Unix Foundation. We've been using and evaluating the frameworks on HolmesGPT to build UI chatbots and observability experiences in OpenSearch, and also heavily leveraging it in the OpenTelemetry demo and the OpenTelemetrica community.
A pleasure to have you with us.
Hi, I'm Satpal. Yeah, I'm Associate Director, Cloud and AI Architect at UBS, Hyderabad. I'm working in the, primarily working in the observability space. Also, creating the architecture for observability, and the resolving the use cases of different line of businesses within the bank. Right, that's my top priority. Yeah, and I love to talk. I'm a Grafana champion as well. I do talk about observability, cloud native, open source softwares. Yeah.
Vadim, would you?
Yeah, absolutely. Nice to meet you guys. I am an independent consultant, and I'm looking for the best solutions for my customers in cloud native, in observability, in Kubernetes. Today we are moving quickly and have a lot of influence from AI. So I am here to learn, to see how to promote what you have, guys, and hopefully we will work together in the future. Thank you.
Thank you. And then I think Utkarsh and Elvin, I believe, if you would like to introduce yourself as well.
Yes, hello everyone. My name is Edwin Mamutov, DevOps and site reliability engineer. Approximately 6 years of hands-on experience designing and operating cloud infrastructure on AWS and Kubernetes. I already worked at the largest bank in Azerbaijan, and we try to build open source observability stack like HTM, and we believe to integrate with AI with stack and get lots of success.
Thank you. A pleasure. Pleasure to have you with us. And Utkarsh, I think you're last if I haven't missed anyone. I know you asked about remote, so okay, yes, a pleasure to have you with us. Oh, that's fine. Is there someone who I missed? I'm always afraid about missing someone.
so we're missing Bodan.
Yeah, but
I'm from my own team. Bodan, go ahead.
Yeah, guys. So I'm also working in the front team engineering department of the Robusta. So if you encounter any UI issue, it will definitely come straight to me. So yeah, just meet me.
Okay, thank you for all being with us, and we're going to be putting the recording on this on YouTube afterwards if you want to share with anyone else. So we're going to have, we have some really interesting updates today. I'm gonna just bring up my screen and share. Give me a second. And bring that up. We actually have one more person joining, so we'll actually do one more intro. Manoj, you're just in time to introduce yourself if you like. We all went through a set of introductions. It's optional, but if you like to, please go ahead and introduce yourself.
I'm not sure he joined.
Oh, I thought I added him in.
Yeah.
So I'm going to bring up the screen share, and yeah, I don't see him here. I thought I added him in. Okay, Manoj, if you can hear us and you'd like to introduce yourself, please go ahead. We were just wrapping up the introduction section.
Sure. Hey, Nathan. Guys, it's Manoj here. So I'm working for HCL Software as a director for cloud operation and DevOps tooling. I have almost around 20 plus years of experience and currently evaluating AI ops tooling actually, and that's why I'm here.
A pleasure to have you with us. Okay, cool. So let me give a quick agenda. Let me just turn on presentation mode. Okay, so we're going to give some project updates. That's mostly non-technical updates. Then we're going to speak about the high-level roadmap and some of the main areas we're building in. There is a ton of going on, so I'm not going to be able to do it all credit, and we're not going to cover everything, but just give some high-level updates of the important things that I think are of interest to the most people. And then we're going to deep dive on 3 different features or 3 different areas. The first is around improving Holmes accuracy. I'll share a few words there on how we think about accuracy in general and like what we're doing to improve that. And then Ari will take you through a deep dive on one of the features we just rolled out in the latest version, the Holmes task list. And he'll explain to you how that works. He'll explain to you the impact on that. He'll explain to you a little bit on how we measure that and like how we decide if a feature like that is a good feature or not. And he'll do a deep dive on that. I'll ask to speak a little bit about the work the Azure team is doing on HolmesGPT. I've written here Azure integrations. It's only a very small part of it. But Pavneet, please feel free to speak about anything there that you would like. I know you prepared some stuff in advance. And then at the end, I will speak a little bit about 2 new Holmes subcommands we've been playing around with. This is still experimental. This is really more of an alpha preview. It's not merged to master yet, but an opportunity to get feedback from all of you, from the community, to hear feedback on stuff that we're thinking about. We're still not committed 100% to building, although we think it's good and we think it's interesting, but really areas where we want to get more active feedback from the community around new ways to use Holmes and how you can embed it in different workflows. Finally, at the end, we'll do a Q&A, but as we go, Google Meet has that hand icon at the bottom, so please feel free to just hit that button as we go and raise the hand. Don't save your questions for the end. We can address it in each section. I think it'll be more relevant then. And we still have few enough people here. We're not yet at the size where we have to worry about too many questions, I think. So that would be, questions are welcome as we go. Okay, so a few exciting project updates. First of all, we're on track to becoming a CNCF project in the sandbox. So we've submitted HolmesGPT together with Microsoft to CNCF, and we've already taken a few steps down that early process. We presented to the resilience tag and had a very good reception there. And the next step along that is the CNCF review meeting. And there have been some delays on the CNCF side. I think Ritra, I don't know if you have an update. You've been staying really on top of that and on the latest status.
I just saw that it's been scheduled for the next month, September 23rd. So hopefully in the next couple of months, we have a good update.
Oh, fantastic. So that's really exciting. And we're on track, and very soon we're hoping to be a CNCF project in sandbox stage. As part of that, we're also becoming a multi-vendor project. So at the Robusta team, we started HolmesGPT, and have a few people on this call. Of course, the Microsoft team has joined us here as well. And, like, that's really exciting for us. Also, to move beyond being just a single vendor project and to move to multi-vendor community project with a lot of vendors and I have the community backing that in supporting HolmesGPT and not just us as a single vendor there. So that's a huge process that we're undergoing together with Microsoft, and we're honored and excited to also have the first non-Robusta maintainer on the team, King Chuan, who due to time zone differences isn't joining us today. But we're going to be alternating the time on these calls so that each time we have a meeting that's more friendly for different time zones. Okay, then two final updates here before we get to the technical stuff. First of all, we have a talk at KubeCon North America. It's Pavneet, the Robusta team, and I believe we're going to be joined by, who is it from Cajun? Is that Edith?
Edith, the CEO of Solo.io.
Okay, cool. From Solo, and then also joined by an SRE, who is also Akamai, who has also been playing with AI apps and playing different approaches. So we're going to have a really interesting talk around that KubeCon. That will be super exciting. Final update before the technical stuff. Pawana has done an incredible job putting together new documentation. So just HolmesGPT.dev, and everything is super user friendly, very detailed instructions on how to get started. How to set different AI providers, different data sources, really extensive documentation. Of course, we're always looking to make that better. So if you don't find something that you're looking for, drop one a message, and of course, we'll improve the documentation more. I think we're doing that on basically a daily basis. We probably have just as many commits to the docs as we do to the code base. So we're trying to make it even easier to get started with Holmes. So if something isn't clear, open up a GitHub issue, ping on the docs and HolmesGPT.dev. Is a really good, fantastic starting point. Okay, over to the high-level roadmap. So there's 4 main areas of focus for us on the open source roadmap for HolmesGPT. And I say main because there are many, many other additional ones from our team and from the Microsoft team, but there are 4 main areas. The first is how do we improve the accuracy of Holmes on complex scenarios? I'm going to speak about that a little bit, and Ari will speak about that as well. But really, if you grow Holmes at a complex scenario, I mean, you have an application that isn't working because it's trying to connect to the database. The database isn't working because there's some other issue with the database. That's not working because there's a network issue. We want Holmes to get to the end of that chain of events and really find the ultimate root cause in that and surface that to the user within 60 to 120 seconds. And we're getting really close to that now. So Ari is going to speak more, and I'll speak a little bit more about the work that we're doing around that and our progress towards achieving that goal. And we have some really exciting new features coming out around that dramatically improve the accuracy. Another area of focus is the CLI and the user experience, really trying to make that more interactive. We've added slash commands recently. We're doing more work there to make that even more useful and user-friendly. We have some other stuff coming out there today. I'm not going to drill too deep into that here, but we'll have some new stuff coming out around that in the coming months, in the coming weeks even. We're also improving the the MCP support, especially for STDIO MCP servers. So to make it even easier to run MCP servers, the Microsoft team is contributing in this area as well. And we're going to have more announcements around this. And then finally, I'll also present at the end a little bit more on the different Holmes subcommands that we're adding and new ways that you can use HolmesGPT on use cases that are very different than what people have just been doing until today. Okay, let's speak a little bit more about the accuracy. In just a moment, I'll hand over to Ari to do a deep dive on this. If you really look at the common failure modes when people throw HolmesGPT at hard problems, it really narrows down to just 4 main failure modes that account for something around 90% of the issues where we want Holmes to do an even better job. One is what we call early stopping. That early stopping happens when you throw Holmes at a problem and Holmes comes back and it says to you, okay, like, great, I investigated, this is what I found, and next steps are 1, 2, 3. And whenever that happens, it's so frustrating because it's like, okay, well, why am I paying you, like the AI agent for, right? Like, why, you know what to do. Like, why are you telling me? You just go off and do that. So Arik has been focused exclusively on that problem for the past few weeks and has made major, tremendous progress on that. We think this problem in the current version of Holmes that came out earlier today is almost entirely eliminated, and he's doing work on the little bit that remains. Arik will show you that, and he'll explain how we've handled this problem. But that almost, on models, we'll speak about this in a moment, that almost never happens anymore. Second is lack of data. So you throw Holmes at a problem, and it just doesn't have the right integrations to answer the question you ask it. But we could fix that by adding more and more individual integrations and data sources and tool sets, and we're of course doing that, but we want to solve that with a broader stroke. We want to solve that with 1 or 2 features that will cover everything. And the way that we're looking at that is, we don't have, like, we only operate with read permissions. It's really core to the data model and like how our users use HolmesGPT, the fact that it's safe, the fact that it's read-only. So you can't give it access to arbitrary commands, but we can have more powerful whitelist capabilities on commands that we know are safe. And we can also allow users to approve things on their own. So if Holmes gets stuck in an investigation and it knows the next command to run, it knows the next step would be to fetch certain data, but it doesn't have access. We want to make it possible for Holmes to request from the user access to that data and then to go off and investigate if the user approves. So that's an area that we're also actively working on. Nicholas is working on that and lead that. He's not on the call today. We're going to have some major features coming out around that in the next few weeks. Third way that we see failures happening is that the context window fills up. That is also an area we're actively working on, and there's some work from Microsoft using faster LLM models to summarize data. There's some other work and other approaches we're looking at as well. That's an area that we think we're going to have very good solutions for. It hasn't yet been the main area we're focusing on. We focused on other areas so far. And then the final one is if you just use a model that isn't good enough. I did some work recently running Holmes with Oldama and GPT OSS. I could get it working. It was really, really painfully slow with Oldama, and the results weren't good enough. So while we're doing work to try and get Holmes working on more and more of the low end in the open source models, today for like really the best results, we find that you get the best results with Sonnet and with Opus. We've done a lot of benchmarking around that. GPT 4.1 and GPT 5 are probably in a close second place there. So a lot of the problems that you see with the weaker models, they just go away if you upgrade to a better model like Sonnet. Final bullet point here before I hand over is, Eric will speak about this a little bit as well, but how do you know if improvement that you make or a new PR is improving HolmesGPT and making it better or making it less accurate? So we invested on that and we're continuing to invest in that. And that's a good handover to Arik, who will give you some more on that. So Arik, without further ado, I'll stop my screen share and please take it away.
Thank you, Nathan. Do you see my screen? Yeah, okay. So basically, as Nathan said, what we're trying to do is to build an AI agent that you can actually ask it any question on production issue, and then you'll get a really deep analysis, and you'll get an actual answer of what is happening, why it's happening, and how to fix it. So I want to go through one example that we had. That is like I have, as an SRE, I have some latency in my cluster. I don't know the cause. And then we want to throw Holmes at it to get an answer. What's wrong and what is happening? Now, the way we work in Robusta is like we get real user scenarios from users, and then we try it with Holmes, and then we build testing around it. We want to make sure that we can take a scenario and test it multiple times and see that Holmes is consistently giving a good answer. And in this specific example, we had a case where Holmes wasn't performing well. As Nathan said, he was stopping too early. So it would do some investigation steps and then would tell you, okay, now you go and do 10 other steps in order to figure out what is wrong. And our goal was actually to make Holmes do the entire investigation and give the actual analysis. So when we started, we were taking a problem and just throwing it at Holmes and telling, this is the question the user asked. This is the tool you have. Now go and figure out what's wrong. And this wasn't working well. And then we tried a few approaches. And the winning approach we found is that we need to help Holmes do the investigation better in a way that we asked him to split the problems into smaller sub-problems, and then we asked him to write down what he needs to do, and then to go over the steps one by one, complete them, and then when you finish your task list, go and do another set of evaluation and decide if you need to do another investigation steps, or you already have enough information in order to answer the question. So we implemented that with Holmes, and we actually got a very surprising result. This is what you see here. This is basically the task list. And then Holmes, first he went on and checked the pods, and then he checked application, and checked network policies and so on. And the answer is really good and accurate. Holmes telling you, we have front-end timeout because there is a network policy. It has some label matchers, and the target service doesn't have the matching label, and it shows you exactly what is the problem and how to fix it. Now, this is a test that was failing 100% of the time in the old method, and now it's actually passing completely. So we figure out that this new way of working is really gives excellent result, and we see this is a big step forward for Holmes, and we've seen it across the board. So now investigation, they are very deep. They take a little longer, but we think that accuracy is the most important KPI for users. So while talking to users, we heard a lot that they don't mind waiting another minute to get an answer, as long as it's better and accurate and it solves their problem. Yeah. If you have any questions, I'd love to answer. Yeah, go ahead, Elvin.
I have a question. I want to talk about our scenarios in the bank. We have done something inside Kubernetes for every application. We have specified its respective owners in applications label in the Kubernetes application. Do you think it will be possible for HolmesGPT to continuously monitor issue in our Kubernetes cluster on its own and notify the corresponding owners about the problems without needing to ask each time through interactive CLI what the problem is?
Can I take this one, Arik?
Go ahead.
So that's what I'm going to show you when I spoke about new Home subcommands. I'm going to show you a new Home subcommand that's called Homes check, and it does just that. So I want to throw the question back at you. I'm going to, with your permission, we're going to cover this after Pavneet, after we answer more questions on the task, and after Pavneet speaks about the Azure integration. And then I will present you what I hope is a good solution. I'm going to ask you for feedback on that. Does that work? But we think it's a really cool use case, and we really implemented something there, and we'd love for you to try it. Other questions, and everyone who asks a question will get a free Homes t-shirt. Encourage participation as well. Juan, can you also take Elvin's details, or Elvin, please send Juan afterwards, and we'll get you a HolmesGPT t-shirt sent in.
How do I get a t-shirt? Does that question count?
You get for participation. You're presenting. So Juan, let's get one as well.
No, I'm just kidding.
Other questions on the task list before we move over to Pavneet and the Azure work?
What's the average latency impact we're expecting as a result of task list in the overall response?
So we have a different set of tests. So we divided it to easy test, medium, and then the hardest test. And accordingly, the hardest test takes longer. On the easy test, we get an average latency with the task list of 30 seconds, more or less, which is a little longer than the before, but we still still accept it.
Yeah, I think I would love for the community to kind of keep us honest on what latency is unacceptable. At what point is the cutoff where we need to start really optimizing for latency? Because I think I agree there is a higher threshold for latency in these cases, but How much?
Yes. One idea, Pravneet, that you brought up in the past, I know, has been add on a -- fast mode flag. So that's something I also started implementing. So we want to give people the option also of disabling some of the more expensive features like task list and saying, no, like just go fast. This is a simple question. And then the other aspect here is, so Arik was like almost exclusively focused on the open source side on the early stopping and like definitively solving early stopping, or at least giving a very good solution that covers it in like 80% of the cases, 90% of the cases. Now that we have something else on that, a lot of our attention is actually focusing as well to how can we decrease latency. So it's like a little bit like a yo-yo where you're swinging back and forth on both sides. And we thought that we had like swung a little bit too much to the fast side at the expense of quality, and then like we swung back over a little bit. We're going to swing back a little bit more towards the middle, but you maintain both. Like each time we're swinging, like you're tightening the bands, so we're getting better results, and we end back up at like something in the middle, but where we still have the benefits of each side. So we are going to see also as we can, because there is a bit of penalty there on latency. So we want to see, can we actually go out and reduce that latency by adding prompt caching, by adding other mechanisms.
Mm-hmm. Yeah, but without losing any of the accuracy benefits, obviously.
All right, do you want to share an eval run just so people have a feel? You don't have to if you didn't prepare anything, but just so people have a feel for how we go about testing this.
I'm not sure I have something. Give me a few minutes and then I'll see if I have something.
So maybe we'll loop back to Arik if he has something ready after Pravneet speaks. But when Arik says we tested this and we like see that it improved, it's like a very rigorous process. Like on defining a bunch of evals or running them hundreds or sometimes even thousands of times in aggregate, like, and then being able to say like, yeah, we know like with this it really performs better on these use cases, and that representative of broad problems. Like it's me.
Yeah, so here I found something. So we use brain trust for testing. This is an example of a high latency test. Another type of latency test. In this case, we have a latency alert on a microservice, and then the root cause is actually another upstream service. In this case, it's RDS running on AWS. And then this is also a hard test that we wouldn't able to solve efficiently before the task list. And okay, I'll walk you through what I see here. So like we have, in this case, 10 executions. Here on the correctness column, we see that it succeeded 9 out of 10. And then I can drill down to any of the tests and see the actual steps that was taken. So here I actually see we started here, and then we started running a tool call. The to-do list is the new tools that is writing the task list. And then we have other tools of running kubectl command and so on, until the last one which gives you the result. And you can really dive in to each and every step and see everything. What was the prompt? What were the tools? And so on. And there's also, you can also see the timeline of the calls. So you can easily see how much time each step is taking. And then if suddenly you see that there is some step that takes a long time, you know where you need to focus. Now, to be honest, I wasn't a big believer on the test, but Nathan was, and I can tell you this is the most powerful tool we have. Like if you're building stuff around AI, invest time in the test framework, and it definitely pays off. If you need to solve a tough problem, it is absolutely not doable without testing. So this is one of the best tools we have.
Now, to clarify as well, I want to just add in, like, this scenario is essentially because a microservice, the microservice has issues because it's trying to connect to the database, and the database is timing out. Even before the task list, and even before this work, Holmes knew to say there's a problem with this database. That's easy, right? You look at the application isn't working. You look at the application, you see in the logs, you see or the traces, and you say like, okay, yeah, the database has a problem, has high latency. But this test doesn't pass if the AI says the database has high latency. That's not enough. You have to look at the database and then figure out what is the problem with the database. And if you don't, that's what we call early stopping. So as like an example, where Holmes, like on the case here that fails, Holmes says it's the database. That's a failure because that's early stopping. That doesn't tell us why is there a problem with the database. So what's impressive about this is like before this, I think this was on, what was the percentage before the task list, Arik?
I think it was very low. But the actual extra step that we made Holmes do is actually using the AWS RDS tool and connecting to AWS, like understanding that the cause is an RDS database, and then connecting to AWS and checking what is the status of the database, and then finding out that it is down or under maintenance or something, and then reporting it back to the user. So, yeah.
So I don't remember the exact details on which eval had which percentage, right? And like what was exactly passing. Like this was either 0%, 100% of the time. Like it was either always 0%, or it was always like it was around 20 or 30%. I don't remember which is which. And then with the work that I already did, like you're seeing that last step going off and speaking to the database, and that's happening reliably, or almost 100% of the time. It's happening 90% of the time. So there still is a residual improvement to do, like on why 10% of the time this gets it wrong. And you look at the traces, you understand, and then you'll do work to optimize on that. But it's a really good example of how beforehand, like Holmes was giving an okay response, say, yeah, the problem is with the database, but it wasn't good enough. And now with the task list, it's going all the way. Okay, Puneet, over to you.
Thanks, Nathan. So I wanted to quickly touch on what is basically Microsoft doing here, right? So I've personally known Nathan for a while now. We've met at several KubeCons, and we've always admired the work that Robusta has been doing with HolmesGPT. Earlier this year, we started looking at building solutions for AKS, Azure Kubernetes Service users, to help them, predominantly starting with troubleshooting, but going beyond and really offering agentic workflows for AKS. And at that point, we were thinking about doing something proprietary or collaborating with open source solutions like HolmesGPT or HolmesGPT. We looked at pretty much everything that was out there in the open source community, and we did our own due diligence, and we really found HolmesGPT to be the most promising solution for long term. And I stress on long term because of the extensibility that it offered, because of its design, which allowed to make changes easily. It was quite decoupled, the concept of toolkit, tool sets, runbooks, etc. And we felt it would be the easiest place for us to jump in and add value, both for AKS customers, but for broader, CNCF and Kubernetes community as well. So we reached out to Robusta, and they were very gracious and open to contribution from our side. They immediately kind of agreed to donate CNCF, and they've been very proactive on that front, which really paved the way for us to start contributing. We've been focusing on 3 key areas. So as shared earlier, Ching Chuan on the AKS engineering team is now a maintainer. We have a few other engineers who are also active contributing. We have PMs, Aritra, who's here, and I were also kind of helping provide feedback and have an active collaboration with Nathan and team. Our 3 main areas that we've worked on and we will continue to work on is 1, improving HolmesGPT's usability for Azure. What that meant was every cloud has quirks. It has its own concepts and paradigms. How do we introduce them and make an open source solution feel like a cloud is for a given cloud, right? In this case, Azure. So we've been adding a lot of those, context tools and runbooks to help make it, plug and play for AKS users. We are collaborating with the maintainers to drive some of the accuracy and UX improvements, really think through, hey, what will make order of, step function improvements in HolmesGPT, right? So brainstorming, actively developing some of the UX improvements as well. And we'll continue to invest there more and more going forward. And then lastly, we are actually building Azure solutions on top of HolmesGPT now. We actually announced something in KubeCon India called CLI Agent for AKS, which is, as the name suggests, a CLI agent for AKS, and is built on top of HolmesGPT, which kind of puts our money where our mouth is, kind of make sure we continue to contribute as Holmes goes into CNCF and drive success for the broader community as well. Yeah, really appreciate the collaboration. to be honest, it's sometimes easier to collaborate with Nathan and team than folks even within my own team. So it's a dream.
Oh, it's a pleasure working with you. It's really a pleasure working with Pavneet and the team. And Pavneet is very modest, but he's also been the originator of a number of very good and useful Robusta features as well. I don't remember if it was you or one of the other PMs that also pushed for the slash commands, for example, but there was a whole bunch of new yeah. So there's been a whole bunch of features that have landed, especially around the CLI experience, that were just ideas that one of you threw off the cuff on like when we were chatting, that have turned out to be like some of the best improvements we made. And that's in addition to all the engineering work as well. Okay. Any questions for Pavneet or questions from an Azure perspective? I know we have some Azure users on the call as well. So feel free to speak up if you want to. Okay, if anyone wants, feel free to reach out to Pavneet or myself as well in private afterward. And let's speak now. Alvin, it's your time. So let's speak about checks. So I'm going to speak about 2 new features that we're experimenting with. And both of these are kind of defined as alpha stage features, not yet merged into HolmesGPT proper. But the goal is to get community feedback and to really see, are we on these? Is there a good and useful use case here that we should focus on more? Or is this a use case that people care about less? And the first one I want to speak about is checks. So I'm going to show that to you. And we have a PR here. It also references the documentation. So this is on GitHub and anyone can try it out. But I want to just show that to you. I'm going to start from let me start from the checks themselves. So take an example of a checks file. And what I did is I put in here a few different checks. Let me blow up my screen a bit. And each of these checks is essentially a query that you want to ask Holmes. So for example, are all nodes in the cluster ready status? That's an easy check, right? Is the service bookstore backend available in default namespace, and are all backing pods healthy? That's also a relatively easy check. But if you think about, there are a few steps to this. First, look at the service, then figure out which pods back that, then check the health on those pods, right? Maybe look at their logs, but it's also a fairly easy check. Here's a check that involves looking at metrics and doing a Prometheus query. Are all nodes in the cluster using less than 85% of their memory capacity, right? Here's a check that's a little bit harder because it's actually fairly ambiguous. Our Java API checker pods in the default namespace healthy. And one of the ways that, from what we've heard so far from discussions with people, that these can be really useful is kind of 2 main scenarios. One scenario is it's just the speed of iteration. Like I could have written a PromQL query for this, but it's kind of a pain, all right? Like you can get away with just writing something in plain English. It gives you a quick and dirty solution. You get up and running, now you're monitoring really in just a minute or 2, as opposed to having to spend a lot of time messing around with queries and setting up alerts in other ways. That's the first way. The second way is to give an additional signal. Think about a case where you have alerts set up. You have a ton of production issues, but I've seen outages where like everything is down except for the little part of the system that says, oh, hi, I'm okay. And like you look at the status page and the status page says everything is fine because like the part of the system that's responsible for reporting on the status page, that part of the system is healthy. Every other part of the system is down and having issues. So what you can do with this is you can use the large language model to apply common sense. And you can use the large language model to look at something, really analyze it by looking at it not according to these preset rules and according to like a hard, very strict check with a threshold like PromQL would, but with a little bit more of a looser sense, looking at it and saying, does something here seem funny? And if it does, the check goes off. So you keep all your additional monitoring, but you get an additional signal. The way these checks work is you can run them with the CLI, and you can run those one off, or you can set schedule and you can run these on the schedule. And then if the check fails, you get a notification. Today, I think it's in Slack or in PagerDuty. And we'll add more stuff there as well. So I want to just show now what the results from running these checks is. So here's the result of running those checks. So this check failed. Every check, I should say, is it gives 2 responses. when you run the check, you get a Boolean, so pass fail, and then you get an explanation as well. One of the interesting things we found, by the way, was that if you ask the LLM to give the pass fail and then give the explanation, you get worse results. If you ask the LLM to give the explanation first and then give the pass fail, you actually get better results because then it thinks through it a little bit more. But okay, so if you look here, then here's the example of that front-end health check. We say, is the front-end healthy in production namespace? It says, no, there's no such namespace. So of course it's not healthy, right? That check fails. Here's another example of a check. Are all the nodes in ready status? Yes, they are. Everything is fine. Here's an example of a check on the Datadog pod. We didn't find direct match on Datadog, but there were related pods. These are restarting. So there's an issue here. Here's maybe just one more example. We have to check error memory usage, and we have something here that's hitting 99%, which is above 90% threshold. It also has unkills in the history. That is definitely failing. And what's cool about these is you can define any checks in just plain English in really a minute or two. Then you run the check and you're good to go. So you give, I'll run it. I'm not going to wait for it to run because it takes a little bit of time to run all of these. We do have some flags to parallelize that, and like we're going to do more improvements around that. But let me just give you a quick preview. I'm going to give it the checks file. That's the YAML file you saw earlier, defining these checks. And this is going to go off and run now. So this is going to run these checks one at a time, gather up data. And then, of course, where we're heading with this, assuming we get positive feedback on this right from the community, then where we're eventually heading with this is that this can run in the background as an operator in your cluster and really just put that cluster on autopilot. You suddenly get a notification, oh, hey, there's something here that requires your attention that you should look at. So yeah, I'll take the question. I see there's a question from Manoj.
Nothing, two things. One, because we are mentioning the check in a natural language, what kind of a validation possible at the backend? We said something, it might convert into a wrong PromoQL, or there's a problem because everybody speaks in a different way, right? So the tone and the way you explain the checks may be different. So the validation of that check, how we do that, it's been done correctly. And the second thing is how complex these checks can go. I mean, it's as simple as that is port health is good or not, but it can be as complex as, is my response time higher than the average response time of last 10 days or last 5 days, something of that kind of a thing, right? So because what I'm saying is because in our current environment where we are not using AI, but most of our alerts are against a baseline which actually got generated through AI from the previous 1 month or 2 months of response time and error rate. We create a baseline out of it, and then we actually compare with that baseline and then do an alert. So is that kind of a check possible? And of course, the second thing is the validation, which I all ask, like, is there any way of doing a human check or kind of a reinforcement learning that, okay, what you are doing is actually correct?
Yes, fantastic questions. So I'm going to answer that. I just want to show also, because this is running. I want to stop it from running in the background because it's distracting. But this is just running now. So it's taking those checks, it's gathering up the data, and then giving you the result after each check. Okay, so I want to go over to Manoj's two questions. I want to take the first one around the complexity. This will come down to which model you're using, and this will also comes down to what I spoke about earlier. With Arik's work on what Arik spoke about with the work on the task list. So all of those features to the kind of the HolmesGPT core agent are then brought in to the checks. They're brought into all the other features. They're brought into another feature I'm going to show you afterwards. So the more improvements that we're making in HolmesGPT, the work that Arik did on early stopping, that has an impact then on the check being able to do more and more complex investigation processes. I think what I would expect, and I'll speak for a second about validation and testing so you can test this for yourself on your own use cases. But what I would expect is that if you use something like Sonnet with the task list, then you'll get good performance. The downside to that is that's a little bit expensive. So if you want to run that on a 30-minute cadence, then that with 100 checks, that would add up. But if you're doing that on say twice a day or once an hour, or even every 30 minutes, you have a small number of checks, then probably the cost on that is negligible. And with Sonnet or other Sonnet level models, I think you get fairly good results. Like I would expect that the type of use case you're giving on the threshold, I expect that actually to be fine. But I'm going to show you for a second now how you do the validation. So Ari showed you earlier the evals, and what I like to show you is also like what that actually looks like for. Let me just bring this up. So we also have the ability to do evals now on the checks. That was part of this as well. And we show you the evals in Brain Trust, but you can also just run it locally with your CLI. So I'm going to just show you an example of this. Let me bring back the screen share. So what I'm going to show you is like how we go about and we validate this like ourselves. We validate the feature works well, for example. So here's an example of a test for a check. What we're doing here is we have a test case, and we have here the definition of the check itself, right? Is there a pod in Nginx and default namespace that is in running state? So really, really simple check. But before this test runs, it runs an Nginx image, and then it waits for something for it to become available. After the test is done, it deletes it. So what that means is we have like an expected state on this test. This test is happening in a controlled environment. We know this should pass. So now you can take this test, you can like test it with Sonnet, you can test it with GPT 4.1, you can test it with 4.0 Mini, you can test this on a bunch of different models, you can run it like 20 times on each, and then you can say like, what percentage of the time is it getting the right answer? And you could do things in this that are a lot more complex. Like this is the same evals framework that Arik showed you earlier in Brain Trust that we're using to evaluate different scenarios. Just to give you an example, like the type of like scenarios that you can do with this. Let me take a different scenario. Here's a different scenario, not for checks, but for Holmes in general. Here's a different eval where we're like creating a namespace. We're sending a bunch of logs. We're setting up a Loki instance. We're sending a whole bunch of logs to Loki. Then we're deleting, like we have logs from a pod, then we delete the pod. We're checking that Holmes can still investigate stuff that isn't around in the cluster, but has historical data in Loki. So you can set up like some really complex validation scenarios, and then you can get like a definitive answer on those scenarios. How is it performing? Of course, that's just validation at the time you're working on this, but it can give you confidence that in like similar scenarios in the real world, it will do well. And it's really easy to generate these. Manoj, does that help answer your question?
Yeah, to some extent. I mean, in the normal environment also, right, the false alerts are one of the biggest problem, right? And I mean, when we start using AI and checks, if that goes the same way that, okay, 80% of the time is accurate, 20% of the time it's wrong, then again, it's become a false alert. So in a normal human analysis, RCA accuracy can be a little bit compromised, that's fine, 80%, 90%. But when you use them as a alerts or use them as a what we call checks, right? Which we call it, we expect 100% accuracy because even a few failure means few false notifications.
Yes. I think you're going to like as well the next feature I'm going to show about the false positives. But you're 100% right. And yeah, the threshold for this to be able to replace some form of human monitoring is very high. And then if you want to get an additional signal, then it also depends on how sensitive you are to it. But I think most people like would you so it actually is a little bit industry dependent sometimes on would you rather have a check like fail? Would you rather a check be a little bit more noisy, but that you know about a potential problem earlier? Or would you rather only notify when like it's absolutely for certain? But that's part of why like we wanted to also let you put in that human language there, because it also lets you adjust the instructions on the check to whatever your preference is.
Sure.
Alvin, I know you were interested in this. Is this kind of what you had in mind, or I'd love to hear some of your thoughts on this.
Sorry, again, please.
I know you were asking about the ability to like run stuff in the background. So I was curious if this would potentially be a fit for that sort of use case, or if you had something else in mind.
Not actually. We don't have a use case, but it's just interesting for me. For example, if we try to run non-interactive CLI, is what's the problem or not? But not we have use case.
Yes. Cool. Okay, so let's go over to one more small little preview, and then we'll wrap things up for today. So one of the main use cases for HolmesGPT is also investigating alerts, and we wanted to bring a little bit more of that to the open source experience as well. So I want to just give a tiny preview of that. So this is a new subcommand of HolmesGPT, also still in alpha, still not merged to master, on a separate branch on this so that people can play with it and give feedback. And when you run it, it connects to Alert Manager, pulls a list of alerts. It'll automatically discover any Alert Manager running in your cluster. You need to port forward you, and it automatically discovers it, pulls the alerts via the Kube API, setting up proxy. And I have here a list of alerts. I'm going to, let's say, just search on not ready. And now I can take any of these alerts and I can hit the E button. So if I hit the E button, you can see that's going over here to this inspector, and that is now in the process of enriching that alert. So here I have a little bit of CLI output so I can see what's going on. That's starting to enrich this coupon ready. If I just go back up, I'm going to go back up here. I'm going to look at an example of an alert that was enriched. Hang on, let me see. I don't see the output on that actually, but we'll give that a second. Wait for this to come in. What I'll get over here on the right-hand side is I'll get the result of that AI enrichment. And one of the things that we wanted to also do here, and I'll show this to you in just a second. Okay, perfect. So here I see root cause analysis, or I see analysis on the business impact. I'm not going to dive too much into each of these. This is actually running on GPT-4o, which is a very poor model, but just to demonstrate the idea. So here we have root cause analysis. This was unschedulable. Here we have a little bit on the business impact. Here we have suggested actions. And then the really cool thing here that we did as well is custom fields. So we let the user define, when you run this, like what are the labels, so to speak. It's almost like you can add a custom label to an alert that is calculated with AI. So let me show that to you. I'm going to quit out of this for a second. When I ran this command, I specified here on the CLI, I said, give me a custom AI column. This is like a new label. This is like a new label that we're adding to the alert that is calculated using a large language model based on all the existing alert data and dynamic information from the cluster. I added a new column called related resource. So now this alert has a calculated label, and you can forward that. So I'll speak about a little bit more how this fits with existing alerts. But now you have a related, now you have a new label related resource. And I said, okay, put this kind/namespace/name format or kind/name format if there's no namespace. And this is like attaching a new label to that Prometheus alert. And then there's a format where this actually can run. There's another command here where you can run this as a proxy on Alert Manager. And then every alert that comes out, like let's say you're sending alerts from Alert Manager to Slack, every alert that comes out of Alert Manager now goes through the proxy. You add on any labels that you want, and now it reaches the final destination, Slack and wherever, just the original alert, plus any of these AI calculated labels that you wanted to attach. And this is a really powerful way to take alerts and then to start to add on all this extra information. So Manoj, if you think about your use case on like labeling false positives, you could start to add on different like calculations here, even labels that depend on one another. You could add on a calculation here, like, okay, who is the right team? You can then add on a calculation, like, is this XYZ known false positive, right? Then you can add on a calculation, like, okay, if either of these is true, then, or you could just add on one big label called false positive or not. With whatever logic you define yourself, it gives it true or false. So this is still a little bit early, but something that we're experimenting with, and we really wanted to, like the checks feature, take this in the direction of allowing users to customize it and define your own columns, define your own logic. We also have a feature that you could only run this on high severity alerts. So because there's a cost to running these with LLM, you could drop it on the low severity alerts, only do it on the high priority ones. So we want to play around with this, and I would encourage everyone, like, take a look at this, and we'd love to hear some feedback. Now, I see there are a few hands up. I don't know who put their hand up. I believe it was Manoj. So Manoj, go ahead.
question. This question is maybe out of the box. What's the name of this UI or console, and how can I view my alerts in this way if I want to? This is Can9s or?
Yeah, so what you do here is if you just look at the command, then this is poetry run. That's just to run this command from Git. Holmes alerts view. You can add on those AI comments. And to run this, let me pull this back up. There's just a pull request here. If I look here for alerts, interactive TUI, terminal UI for viewing and alerts. So you would just check out this branch. I don't think we don't have actually any comments on the PR, but if you look at the file was changed, there's fairly extensive documentation. We added like a whole walkthrough on this, on how to use this feature in both of the modes where you're proxying Alert Manager and the mode where you're viewing that like alerts user interface in your terminal. So there's pretty extensive documentation. And as always, we're also on the Slack community, and we have the Robusta Slack community. So feel free to ask us questions on there to share your feedback, or just open up tickets on GitHub.
Okay, thank you for the information.
Our pleasure. Yes, Aniruddha.
Hey, one question regarding like everything is done as a CLI today, and there may be other modes of interaction. Is there any ongoing work or plans to support AGUI protocols for UI kits or UI platform builders?
So I'd be interested in hearing a little bit more. You want to follow up on that or open a GitHub issue?
Yes.
I would love to continue some of that discussion around it. We haven't looked at it ourselves. We do, like as a vendor, we have our own UI that we develop on top of this.
Yes.
For capabilities, but I would love to look at more around. Are there better ways we could do that for the community? We have an HTTP server as part of the open source that people can access.
I think we were thinking of having an HTTP server-ish approach, but also following a protocol for agents to communicate with UI more clearly using AGUI, which is coming up as a pretty standard protocol, universally kind of adopted, getting there. But I think it's a good protocol that we could start aligning how UI systems can offer context and have chat interactions multimodal. Definitely a student issue. Thanks.
Thank you. I would love that. So I'd love to take a look at that and just share in there like a little bit of the context on how you would envision it working, and then the suggestion on the protocol. And we'd love to take a look at that. It sounds like a really cool use case.
Perfect. From OpenSearch dashboards, we were kind of communicating with Robusta via the AGUI protocol. So we made some smaller changes, but this would be more like nicer to get in the official release. So thanks so much. I'll follow up.
Absolutely, our pleasure. Thank you so much. Alvin.
I have two additional questions. Firstly, starting today, I am going to start using HolmesGPT in our environment. The integration list mentioned Prometheus, but we use the LGTM stack. That means we used Mimir instead of the Prometheus. Is a parallel integration with Mimir possible? Logically, both can evaluate queries over from QL.
I believe so, but I'm gonna check the docs. Let me check. I believe the answer is yes, and I think we even mentioned it explicitly in the docs. We might split it out from Prometheus to a separate Mimir page even, but I believe, yeah, okay. We have, it says Grafana Cloud, but I think it's any.
Okay. But is this on Grafana Cloud, or is the Mimir is our hosted OSS version? It works.
It can work with both self-hosted Mimir and with the Grafana Cloud.
Okay. Thank you for information. And second question, is there any possibility that our data could be sent to a third party through HolmesGPT? How can we be certain about this?
So it's up to you. By which I mean it depends. Which the primary question there is which model provider you use. You'll have to, when you use HolmesGPT, you'll have to bring like API key for Azure AI or for a local model that you're running. So that's the primary area where you'll make that decision. Now, if you take the HolmesGPT Helm chart, then we also have an option to send exceptions via Sentry, and there's a flag in the Helm chart to control that or not. So if you're using the CLI, that's not relevant, and then there isn't even that option. If you use the Helm chart, then there's a flag if you want to send exceptions to Sentry or not, and that's referenced here in the documentation. And then, of course, if you choose to use this with a different provider, like, or if you choose to take like the Robusta SaaS platform, for example, then of course we have, we take data on our SaaS unless you do an on-premise deployment. But if you just take the HolmesGPT CLI in the open source, then the main question would be which large language model provider are you sending data to? You could take a self-hosted model, but we do find you get the best results with Anthropic Sonnet, either via Bedrock or Gemini or via Anthropic themselves. Does that answer the question?
Yes, it's clear for me. Actually, we have a plan to create self-hosted model in our environment and to integrate with HolmesGPT.
Oh, fantastic. Very cool. So I think in your case, no, nothing would be sent out of your environment then.
Okay, thank you for information and clarification.
Our pleasure. You said you had two questions though. Was that both of them or just the first?
Yes, first is Mimir, second is this.
Oh, right. I'm like an LM. I'm bad at counting. Pawan, do you mind, while we're here, Pawan, maybe we should update the documentation as well so that we say Grafana Cloud or Mimir, or we have a section on Mimir and then we have a section on Grafana Cloud that just references you to Mimir. That would probably help so that people can see that more clearly. Okay, Aniruddha.
Sorry, I already went. I didn't try to lower my hand. I'll do that. Thanks.
Okay, so unless there are more questions, I think we are good to go. And if anyone wants a Robusta or HolmesGPT t-shirt, message Pawan and we'll get you one sent. And thank you all for joining us. It's been a pleasure, and we're going